Yeah, I think we are on that. Okay, hello everyone. Welcome back to 360 DG's one more interview preparation session. So I have collected few interview questions that have been asked in recent interviews. So we will go through all these interview questions. If you know the answer, please comment in the live chat session, and we'll discuss the answer after one hour, one and a half minute later. So yeah, get back. We'll start the very first question. The logistic regression used for classification, then why it is called as a regression? Yeah, this is the very first question. If you know the answer, please comment in your live chat session, and we'll discuss after 1 minute. It is one of the questions that has been asked recently. If you know the answer, just comment in your live chat session, and we'll discuss in a minute. Okay, now we'll discuss the answer. Yeah, as you guys know, we will be using this logistic regression for it is one of the basic algorithm for the classification models, and just like decision tree, but we'll use decision tree for both regression and classification. But especially when it comes to the logistic regression, will be using for only classification, and we are using logistic regression for classification, but it is named as a logistic regression. Why is that? Means the underlying techniques which we are using to classify, that is just similar to the regression, linear regression. Yeah, that is the main reason it is called as a logistic regression instead of logistic classification. Yeah, I hope that is clear. Yeah, it is one of the question that has been asked in recent interview. One of my friend attended the interview. Yeah, this is the one question he's been asked. The very next question: explain the correlation. If you know the answer, just comment in live chat, and I will discuss in a minute. Yeah. Okay. We'll discuss the answer for this question. Yeah, it is a very basic question. So the correlation is the relation between the independent variables that you can see. And yeah, see, when we have like high correlation, we will be going for different techniques, right, in order to decrease that relation, the correlation. Yeah, correlation is used for the measuring and also for estimating the quantitative relation between the two variables. That could be independent variables and that could be dependent variables, and in between dependent and independent variables. Correlation measures how strongly two variables are related. Example like income and expenditure and demand and supply. Yeah, it is very basic question actually. Even though it is basic, but these questions are asked in the interview. Okay, well, let's move to the third question. That is, can logistic regression used for more than two classes? Like, if you didn't understand the question, like when we are applying logistic regression for classification, we'll be having two labels, right? Like yes or no, something like that. Can we use the same logistic regression for more than two classes? Is it possible or not? Just comment in live chat, and we will discuss the answer in a minute. Okay, let's discuss the answer for this question. So, yeah, for logistic regression, we don't really use more than two classes. By default, logistic regression will be used for binary classification itself only, and yeah, we can use for multinomial regression, but we don't really use for more than two classes. So yeah, it is also one of the question. Yeah, I mean most of the people don't really know the answer. So yeah, this is the answer for the third question, and let's move to the fourth question. What is true negative? We'll be using this true positive, true negative in classification, right? Confusion matrix. So it is very simple question actually. Just answer whether, I mean, what exactly the true negative. Yeah, even though it is very simple, but it is very frequently asked question in interview. So yeah, when it comes to the answer, when model correctly predicts the negative class, and that is called as a true negative. Let's say, for example, umpire given batsman is out when he is already, when he is out. So it is a true negative case. So let's move on to the next question, that is fifth. What are the evaluation metrics for the classification? What are the evaluation metrics for classification? So comment down all the matrices that we use for classification. Yeah, this is very important question actually. One should remember the matrices that we'll use for classification. I couldn't able to see any comments. I don't know whether you are not answering or maybe some technical glitch. Anyway, I'm moving on to answer. See, when it comes to the evaluation metrics for the classification, it depends on the whether you have a balanced data set or not. If you have a balanced data set like classes, if you have a balanced classes, yes or no class, in that case, we'll consider accuracy, precision, recall are a good value, evaluation matrices. But when you have an imbalanced data set, then you are supposed to consider ROC, AUC, like area under the curve. Even we can use recall and precision for the unbalanced data set. I hope you are understood. For balanced data set, we can directly go for evaluation metrics, that is accuracy. And to balance precision recall, we can calculate the F1 score as well. But if your data set is imbalanced, then you should consider precision recall, F1, ROC, and AUC. If you don't know what ROC means, that is receiver operating characteristics curve that you can and area under the curve. In case of imbalanced data set, you are supposed to consider this. You can't really go for accuracy when your data is imbalanced. Even though you are getting most of the, I have observed most of the people who are while they are doing the project, even though their classification data set is imbalanced, they will directly go for accuracy, like normal confusion matrix accuracy. So that is not the good. That's not good because when your data set is imbalanced, so it doesn't matter whether your accuracy is good or not. When your data is imbalanced, you are supposed to go with precision recall, ROC, and AUC curves. I hope you understand that one. So let's move on to the next question. That is sixth. Evaluation metrics for regression. We have discussed evaluation metrics for classification. Now answer, what are the evaluation metrics for regression. Guys, these questions are very important. Have asked different, few people and gather the data. So be sure learn these questions before going for interview. We'll discuss the sixth answer in a minute. Please try to answer in live chat. Okay, let's discuss the answer for the sixth question. Yeah, when it comes to the regression, we will mainly using these three evaluation metrics, that is mean square error, root mean square error, and mean absolute error. These are the very common technique, common matrices that we will use the evaluation of regression models. And the very next question is, what do you understand by outliers? Try to answer in live chat, and we will discuss in a minute. This is very basic question. Okay, let's discuss that. See, basically, an outlier means it is an extreme value, like whether it can be a low value or high value. So we'll calculate the outlier depending on the mean value. So if it is too far from mean value, that will be considered as an outlier, right? So, and one more thing, no? See, you can't really just tell outlier by just looking at the data. If you have a like maximum value, that will be outlier, and if you have like minimum value, that will be outlier. You can't really decide based on that itself. You have to look at the data. It depends on different data set. Depends on the data frame as well. Let's say you are working on retail data, and in that you have one 10 rupees product, and you have one more product that cost about more than 1,000 rupees. So based on that, you can't really say 10 rupees product is an outlier. So it's completely depend on different data frame that you're working on. Based on that, you should consider whether it comes under outlier or not. I hope it is clear. So yeah, let's move on to the very next question, that is trimming. So we have a different outlier detection and removing techniques, right? So it is one of those. Just tell me the answer for what exactly is trimming, what happens when we do trimming. It is okay. Just try to answer in live chat session. Anyway, we're gonna discuss in a minute. Yeah, Uma and Yashwanath. Yeah, absolutely right. See, yeah, trimming it is one of the outlier removing technique. In this case, now we will just remove whatever the outliers we have found in a data frame. We will completely remove from the data set, or you can say data frame. So in this case, we will be losing the entries from our data set. So most of the time, this technique is not advisable because you are losing the data from your data set. Okay, let's move on to the very next question. That is, what is vincerization? Try to answer in the chat session. Anyway, we will be discussing in a minute. Yeah, Venki, yeah, we will remove the outliers in the trimming. These are not completely extreme values. It depends on data frame to data frame again. Yeah, that is absolutely right, Uma, Mahesh. In case of vincerization, we will convert those outlier into upper band and lower band. We'll create, substituting the upper and lower limit. Yeah, that is absolutely right, Bengi. In case of vincerization, we don't really remove the values. We will convert those values into upper limit and lower limit. That is absolutely right. Yeah, that is what vincerization do. Yeah, and one more, the very next question that is related to trimming and vincerization. What are the differences in between trimming and vincerization? Try to answer in chat session. We will discuss in a minute. Yeah, Venki, that is absolutely right. Try to answer what is the difference between trimming and vincerization. Yeah, well, we'll discuss about yeah, absolutely, Ashwin. The trimming, yeah, it is removing the outliers, and when it comes to the vincerization, we will be replacing those outliers with upper limit and lower limit. Yeah, that is absolutely right. Let's move on to very next question. That is, what is true positive? We will be using evaluation matrix for classification, right? In that confusion confusion matrix, we will be having true positive. Answer what exactly it means. If possible, take one example and you can explain it. We'll discuss the answer in a minute. Okay, now discuss about the answer. I don't think, see, Uma, that is not the true positive. Getting is output is getting is false, and it is showing it's not correct, Uma. Yeah, Syed, yeah, that is absolutely true. Uh, right, when a model correctly predicts the positive classes, that is when we call the true positive case. Let's take an example. When umpire gives batsman not out when it is not out, that is a true positive case. Both predicted and actual values is true. Yeah, that is true. Venki. Yeah, Supra. Yeah, that is absolutely correct. Okay, let's move on to the next question. That is, describe dimension reduction in machine learning. What exactly is dimension reduction? If you know the answer, try to answer in chat session, and we will discuss in a minute. about the answer. Okay, let's discuss the answer. See, when we are working on different data frame and you are considered some model and you have so much dimensions in your data, in that case, you try to reduce those dimensions. One of those dimension reduction technique, that is PCA. Dimension reduction is a process which is used to reduce the number of random variables that are features. Random variables mean those are features under consideration. Dimension reduction can be like feature selection, feature extraction, and PCA. These all comes under dimension reduction techniques. Yeah, Uma, absolutely. Yeah, Venki, yeah. Principal component analysis also comes under dimension reduction. Yeah. Okay, and the very next question is, what is false positive? I intentionally didn't put all these false positive, false negative questions together because you can easily figure it out if all are together. That is why I kept other questions in between those. Try to answer what is for false positive, and if possible, take one example. And we will discuss answer in a minute. Yeah, when it comes to answer, Yashwant Kumar Empire gives out and batsman is. Yeah, when model is incorrectly predicts the positive class, it is said to be false positive. Yeah, it is also called as a type 1 error actually. See, in interview they can also ask like what is the type 1 error and explain. They don't really ask you what is false positive. They simply ask you what is type 1 error and explain, and if possible give one example. So you should know what exactly the type 1 error is. For example, umpires gives batsman not out when it is out. Yeah, prediction is not equal to actual. Actual value is true, predicted is false. Yeah. Yeah, and one more question is what is false negative? False positive is already there, so you can easily get what exactly the false negative is. So we can will directly go to the answer session. When model is incorrectly predicts the negative class, it is said to be a false negative. It is also called as a type 2 error. Please make a note of it, like what exactly the type 1 error and type 2 error. Type 1 error is also called as a false positive, and type 2 error is also called as false negative. When we will work on project, that too medical or any life sciences projects, you should be very careful about this type 1 and type 2 error. See, always accuracy is not the absolute value. You are supposed to take care of some things other than the accuracy. And when it comes to the life sciences projects, these are mandatory, like type 1 error and type 2 error. So you should be you should be aware of this type 1 error and type 2 error. Okay, let's move on to the next question. Yeah, this is also one of the important question. How do you calculate accuracy in classification using confusion matrix? So in confusion matrix, we will be having true positive, true negative, false positive, and false negative. By using those, how are you going to calculate the accuracy? If you know the answer, comment in live chat session, or else we'll discuss in a minute. And guys, you are supposed to learn how you're going to calculate the accuracy just by looking at the confusion matrix. See, this is very important question. They will provide you the confusion matrix, and you have to calculate accuracy. It happened with many students, so please practice it. If you know what exact, I mean, if you know formula for accuracy, it is easy. I mean, it's not a difficult task. You just need to write down the formula for accuracy that we will use when we are working on confusion matrix. And even while you are giving IBM tests, these kind of questions will be asked. So you should be aware of these questions. Yeah, Venki, yeah, that is absolutely true. And can you tell in terms of true positive, true negative? Yeah, that would be good. Yeah, exactly, sir. Yeah, true positive plus true negative by total. Yeah, absolutely, sir. Shoaib. Yeah, that is true. Dividing the number of correct prediction by total number of prediction. That is true positive plus true negative by true positive plus true negative plus false positive plus false negative. When you are given the matrix, that is confusion matrix, you can simply calculate here only. Let's say this is a matrix. Yeah. You will be given number, something like that, based on data set. In interview, there are so many people who has faced this question. You just need to figure it out, answer by just looking at confusion matrix. If you know this formula, you can easily figure it out. I hope that is clear. Okay, let's move. Sorry to ask, but can you briefly describe what confusion matrix is? See, Yashwant, confusion matrix we will be using for classification evaluation matrix. It is an evaluation matrix for classification models. Based on this only, we will calculate how much accuracy is your model giving. I hope you understood. Confusion matrix is the evaluation matrix for classification models. When you are working on classification models, you need to find out accuracy, right? So for that, we will be using the confusion matrix. I hope you understood. Okay, let's move on to another question. Next question. What are L1 and L2 regression also called? Like what L1 and L2 regressions also called as? Yeah, this is one more question. You are supposed to know type 1, type 2 errors, and you should know what are L1, L2 regressions. These L1, L2 regression has another names. You should remember those. And if you know why do we use L1, L2 regression, comment in chat box, in live chat session. Yeah, Suprabhat. Sir. Yeah, absolutely. L1 is also called as lasso regression, and L2 is also called as ridge regression. Can you guys tell when exactly we'll use L1 and L2 regressions? So we will use L1, L2 regression for regularization, and these are also used for feature selection. Yeah, this one is very important question. Every single, I'm telling out of, the people who have attended interview, out of 100, 90 person, people definitely face this question. What exactly R2 and adjusted R2, and which is more reliable? If you know the answer, use a live chat session to answer, and anyway, we will discuss in 2 minutes. R2 is coefficient of determination. Just R2 shows which is Supravat. R2 is coefficient. Yeah, Supravat, R2 is the coefficient determination, but which one is reliable, whether it is R2 or adjusted R2? See, I'll explain you the difference between the R2 and adjusted R2. Anyway, R square means you might have, you already know the word exactly the R2. R square measures the proportion of variation in dependent variable explained by C. When you are working on regression models, the output variable changes based on input variables. Input variables also called as independent variables, and output is, that is the target variable, that is called as a dependent variable. Based on input variables and output variable changes. Yeah, that is only it has been written. R square measures the proportion of the variation in your dependent variable explained by your independent variable for a linear regression model. When it comes to the difference between the R square, R2 and adjusted R2, see, when you are adding one feature into your data frame, when it comes to R2, it doesn't see whether that particular feature is important or not. It simply increases your R square value. And when it comes to adjusted R2 value, when you are adding some features into your data frame, it will see that feature, is it important or not. If that feature is important, then it will R2 square value will be increased. If it is not if it is not important, in that case, adjusted R2 penalizes that feature, and the R2 square value will be decreasing. So you can figure it out like which one is reliable. One, that is R2, add any feature. Anyway, it is going to increase your R square value. And in other hand, that is adjusted R2 square, R2, that it absorbs whatever the feature you are adding, whether it is useful or not. If it is useful, it increases the R square value. If it is not useful, it penalizes the model and decreases the accuracy. In this case, you can just by you can say that adjusted R2 value will be more reliable compared to R2. That is also called as R square value. No problem. I hope you guys understand. Uma, we don't really consider R2's value because it doesn't, penalizes if the feature, whatever the feature we are adding, if it is not that useful, anyway, it is going to increase your R square value. So it is not a reliable one. Adjusted R2 is a somewhat advanced value, you can say. Advanced technique, you can say. I hope you understand. Yes, sure, absolutely. Adjusted R2 gives which features are affecting where are. It doesn't really, but it will give an indication. It will increase the R square value. Adjusted R square value, it checks whether whatever the column feature you are. Yeah, let me explain clearly. See, you have R2 and adjusted R2. Just a minute. Yeah, you have R2 and adjusted. You can say R square value also, no issues. So just say you have one data frame, DF. In this data frame, you have, let's say, 4 features. If you are adding some one more, if you are adding one more feature, that is fine. In case of R2, let's say initially you have R square value something like 85, and it is 84 point something. When you are adding the new feature into the data frame, R square doesn't see whether that particular feature is important or not, whether it is gonna give some inputs like important information for that particular model. Without checking anything, it will simply increases the R square value. I'm just giving like random value. It increases the R square value. When it comes to adjusted R square value, it will check whether this whatever the feature that we added into the data frame, whether it is useful or not. If it is useful, it will increase its R square value to some value. But if it is not useful, it will penalize the model and it will decrease its R square from 84.5 to some 83 something like that. So here R2 blindly increases the R square value, but when it comes to adjusted R square value, it doesn't do that. It will check whether whatever the feature we are adding, is it useful or not. Then only it will increase R square value or it will decrease R square value. I hope you understand, Venki. Now you guys understand like what is R square and adjusted R square and which is more reliable. If you understood, please comment in live chat session that you understood. Yeah, Uma. And Venki? Okay. Yeah, that is all for today, guys. Yeah, these are very important questions. Please go through it because I have collected from different, I mean, few peoples that they have attended like from their interview sessions. They have attended interviews recently, and they got they have been asked these questions. So I thought it will be useful for other people. That is why I shared. This question is very important actually. Please go through it. If you haven't seen from the beginning, it will be there in YouTube, so you can check it out again. So yeah, that's it, guys. We'll see you tomorrow. Until then, bye.